Hello then welcome to a brand new video. This is How Beyond Numbers, where we learn maths the easy way. Now in this lesson we are looking at types of sets, and by the end of this lesson you should be able to identify and then describe the various types of sets, and then you should also be able to use the correct terminologies to describe the relationships between sets. Without much ado, let's quickly go into it. So as we have been able to look at what sets are, and then there are various notations are, as I've said in our introduction, we are on the types of sets. Now the first type of set we'll be looking at is an empty set. So the word empty means what? Nothing. And the empty set can also be called the null set. So this is the first set we'll be looking at. A null set is a set with no element at all. This set has no element, you see, and we usually notate it with what? Something like this. You just write a circle or O, then you cancel it out, or a curly bracket that has no element. This is what we call an empty or a null set. A typical example of this is all sets of, let me say, prime numbers that are greater than 2 and are even. Set of prime numbers that are greater than 2 and are even. There is definitely no prime number that is greater than 2 and is even, you see. So if you are going to let this set be set A, then set A is actually a null set. So that is it. The next types of sets we'll be looking at are finite sets and infinite sets. When you say something is finite, it simply means it ends. Okay. So for finite sets, these are sets that has a countable number of elements. They have a countable number of elements. And if you say it has a number, its number of elements are countable. It means you can actually count them. So if you have set A, which has elements, let's say 1, 2, 3, and then 4, we can tell that it has what? 4 elements in it. You see, we can count them out. 4 elements in it. But then for infinite set, on the other hand, it is a set with endless elements. You see, there are so many elements in this set that you can't count. So example, if I have set B, and then I say set B is the set of counting numbers. 1, 2, 3, 4. It goes on and on because the counting numbers are so many. And because we can't write all of them, we end it with this 3 dots over here to show that what? It is an infinite set. The number of sets goes on and on and on and can't be counted. So that is it for finite and then infinite set. The next one we'll be looking at is equal sets. When we talk of equal sets, then two sets are said to be equal if they have exactly the same element. They have what? The same element regardless of the order. So far as the elements within the two sets are the same regardless of the order, we say they are equal. Now, a typical example is this. So if I have set A, and then the elements of set A are 2, 4, and then 6. And I have another set, let's say set B. Its elements are 6, 4, and then 2. You realize that the elements in set A are the same elements in set B, regardless of the order. In set A, they have been arranged in what? Ascending order. In set B, in descending order. But it still doesn't change the fact that they literally have the same elements. If this happens, we say what? The two sets are equal because their elements are what? The same. And we just write it with the equal sign. So set A is equal to set B. As simple as that. Then comes another we call equivalent set. So for equivalent set, we say two sets are equivalent if they have the same number of elements. If they have the same number, take note of this here. It says what? Same number. You could have two sets whose elements are not equal, but they can be what? Equivalent. So let's look at some example here. If I have set C, whose elements are A, B, and then C. And I have set D, whose elements are what? 1, 2, and then 3. Now, if you look at these two sets carefully, they have 3 elements each. You see, so this has 1, 2, 3. It has 3 elements in it. And this also has what? 3 elements in it. We say they are equivalent because they have the same number of elements. You get it? So we say they are what? Equivalent. So with that said, we denote that with what? C is equivalent to D. You see, C is what? Equivalent to D. Now the next set we'll be looking at is a singleton set. Before we go to that, I would like you to know that all equal sets are equivalent. All equal sets are also equivalent sets, but not all equivalent sets are equal. Because you see, these two sets we have over here, they are equivalent, but they are not equal. On the other hand, these two sets we have over here, they are equal. And yet still, they are also equivalent because they have the same number of elements, 3 each. Now let's look at the singleton sets. This is a set that contains only one element. A set that contains just one element. Single. That is where the word is coming from. One typical example is the set of prime numbers that are even. You only have one prime number that is even. You see? And then that is what? 2. So this set here is a singleton set. You get it? Okay. Now the next set we'll be looking at is called a subset. Subset is denoted by this symbol over here. It's like a C. It's like a C, but then we just extend it this way. Okay. So talking of subsets, then you might be having two sets in mind. So let's say we have set A and then set B. Okay. Now, if set A is a subset of set B, then what that means is that all the elements, that is, so I'm saying if set A is a subset of B, so it means all the elements in A are inside of B. You see, all the elements in A are inside of B. So let's look at this example here. Let's say I have set A, which has elements 1 and 2. And then I have set B, which has elements 1, 2, 3, and then 4. Now, if you look at these two sets carefully, all the elements in A are in B. You see? So we say A is a subset of B. And we write it as A is a subset of what? B. You get it? So A is inside of B. A is a subset of B. This is how it is denoted. There are calculations we would have to do on this. That is determining the number of subsets and all that. But we won't do that in this lesson here. We'll do it in another lesson. Hence, let's look at our last type of set called the universal set. The universal set is the main set that contains all the elements being considered. and we usually denote it with the letter U. You denote it to what? The letter U, something like this over here. Okay, so that is the universal set. So let's take an example and then we'll be able to really explain what the universal sets are. Universal set can be something like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Now, out of this set, if I take set A to be even numbers less than 10. So we can write the following for that. If I take set B to be odd numbers less than 10, then we can take the following also from what? That. You would realize that all these sets here are taking their elements from this bigger set over here, because this is the main set we are talking about. Numbers that are less than 10. Whole number, or let me say counting numbers that are less than 10. And because they are all taken from this universal set or the mother set, that is why we call it the universal set. We will end this lesson here. In our subsequent lessons, we'll look more on what sets. I do hope this lesson was helpful. And as usual, I'll leave an assignment or a try work for you. So here you have your try work, 2 sets of questions. You can read them through, try and understand before attempting them so that you can be able to answer as well. This is Hub Beyond Numbers, where we learn maths the easy way. I do hope this video was helpful. You can always choose to subscribe if you so do wish, so that you'll be notified anytime I release a video. Stay blessed, then stay safe. Bye for now.